Hi everyone, now we will talk about testing and modeling users. User testing is a practical experiment based method used to find out how well real users can use a product to complete typical tasks. Developers measure key indicators such as the time taken, the number of errors, and the paths users take through a task. Especially in systems like websites or applications, it's often supported by additional methods like observation, satisfaction survey, and interviews to gain a fuller picture of usability. While user testing shares root with scientific experimentation, its purpose differs. It aims to improve design, not to generate new scientific knowledge. So, in practice, user testing is flexible. Most studies use 5 to 12 users, but smaller, quick, and dirty sessions can give early useful insights under time pressure. It must still be carefully planned and executed, even if conditions aren't perfectly controlled. The key goal remains to identify usability issues efficiently and make design improvements based on real user behavior. Um, so, this case study evaluated the revised version of the Medline Plus health information website after expert heuristic feedback. The main goal was to see whether the new categorization and navigation structure actually helped users find information more easily. A key challenge for large medical websites. 9 participants were recruited from local healthcare clinics in Washington, D.C. Rather than focusing on demographics, the study prioritized users with moderate web experience who regularly searched for health information. 5 realistic health related tasks were designed, such as finding details on skin cancer, pregnancy safety for Prozac, and treatment options for breast cancer. Each participant followed the same scripted instructions to ensure fairness and consistency. Testing was carried out in a lab like condition where the evaluator greeted each participant, explained the purpose, and observed them completing the tasks. This structured, consistent approach ensured that any performance differences reflected usability issues, not variations in how the test was conducted. The data collection process for the Medline Plus study was carefully structured to capture both performance and user experience. Before testing began, clear success criteria were established. For instance, each participant needed to locate between 3 and 9 relevant web pages to complete a task. During testing, every user interaction was recorded through logs and video to document search behavior, navigation paths, and time taken. These recordings helped evaluators analyze completion times and understand how users approached each task. Beyond performance data, evaluators also gathered qualitative information through satisfaction questionnaires and debriefing sessions. They noted external websites visited, negative reactions, and any verbal or non-verbal cues of frustration. This combination of quantitative and qualitative data gave a complete picture of how usable and effective the revised Medline Plus interface was. User testing must be carefully structured to maintain fairness and consistency. The DECIDE framework provides a logical way to plan, from defining goals to collecting and analyzing data. Goals should be clear and measurable. For example, while the overall goal may be to test usability, specific questions like how fast users can complete a task or whether they can find an item easily help focus the study. User testing belongs to the usability testing paradigm. It uses multiple techniques such as recording user behavior, logging interactions, and using post test questionnaires and interviews to gather both performance data and user impressions. Most importantly, the test design must ensure that what is measured truly represents what is being tested. Designing realistic goal oriented tasks is crucial for meaningful results. Each task should simulate something users would actually do, such as locating information or completing a simple process. Quantitative data like completion times, number of errors, or frequency of help usage allows evaluators to benchmark usability. Short, simple tasks early in the session help users relax and gain confidence before tackling complex ones. Equally important is selecting representative users. The chosen participants should reflect the actual target audience, their age, skill level, and familiarity with similar systems all matter. For example, HutchWorld specifically included cancer patients with different level of online experience. Tools like short screening questionnaire help ensure that the participants accurately represent real users. Preparing the testing environment is critical to ensure results are not influenced by outside factors. Companies like Microsoft and IBM has purpose-built usability labs that allow control testing without noise, distraction, or interruptions. These labs often include several sections: a main testing area where the user interacts with the product, an observation room with with a one-way mirror for evaluators, and sometimes a viewing room where managers can watch live sessions. Cameras, microphones, and keystroke loggers are used to record behavior, gesture, and interactions in detail. The setting can be customized to resemble real world context, such as an office or hotel reception, depending on the product. For smaller organizations or researchers with limited budget, mobile usability setups are a practical alternative. Portable recording systems can transform any quiet room into a temporary lab, making user testing accessible and adaptable for different environments and different products. In user testing, experiments often vary one or more factors called independent variables to see how they influence user performance. For example, an evaluator might test wrote, whether users read faster with a specific font, for example, Helvetia or Time New Roman. Control conditions such as reading printed text help provide a baseline for comparison. When two or more variables are studied together, the design becomes more complex. For instance, comparing system versions alongside user experience for like beginners versus experts forms a 2 by 2 setup, allowing researchers to see both main effects and interactions between variables. Performance is measured using dependent variable like task completion, time, or error count. Together, these data help evaluators understand which design performs better and why. Next, in user testing, selecting how assign participants across condition is crucial to ensure reliable results. The different participant design uses separate groups for each condition, avoiding learning effects but requiring more people and risking variability in skill or experience. The same participant design allows everyone to test all conditions, reducing participant needs and individual variability. However, it can create order bias where experience from earlier tasks influences later ones, which is minimized through counterbalancing, alternating task order among participants. Lastly, the matched participant design pairs users with similar traits such as experience or gender, assigning each pair to different conditions. This method helps when participants can test both conditions, but it's difficult to ensure all influential traits are evenly matched. In user testing, the data collected focuses on objective performance, how long users take to complete tasks, how many mistakes they make, and their overall speed or the accuracy. Once the data is gathered, the next step is to analyze pattern across conditions to see if one design performs better than the other one. Graphs are quick and effective way to visualize performance differences and spot any unusual or extreme results. Statistical tools such as t-tests help determine if observed differences are truly significant or just due to change. For example, a t-test comparing reading speed between Helvetia and Time New Roman font could confirm whether one is genuinely faster to read. If no significant difference is found, it means the original assumption that one font is easier to read is not supported by the data. The GOMS model was introduced to describe how users mentally plan and perform actions where interacting with a system. It breaks user behavior into four core components that are uh, goals, operators, methods, and selection rules. Goals represent what the user wants to achieve, such as deleting a word. Operators are the mental or physical actions, like moving a cursor to or pressing a key. Methods outline the specific steps for achieving the goal, like using a menu or the delete key. Selection rules help the user decide which method to use when more than one is available. For example, in Microsoft Word, a user may delete text either through the menu option or by using the delete key from the keyboard. The choice depends on context. Larger text selections favor menus, while smaller edits are quicker with the keyboard. The GOMS model offers a structured way to compare different system designs by predicting task efficiency before implementation. For instance, in Project Arnstein, researchers used GOMS to show that a proposed workstation design would actually slow operators down, saving the company from a poor investment. However, the model has limitations. It works best for short, repetitive, and predictable tasks performed by the experts. Real world behavior, with its interruptions, multitasking, and learning variation, is much harder to model. Thus, while GOMS can help compare systems efficiently, it does not capture the full complexity of how real users interact in everyday environment. Finally, Fitts law is one of the foundational models in interaction design, predicting how long it takes user to move a pointer or finger to a target. It shows that the movement time depends on two things: how far the target is and how big it is. Simply put, larger and closer targets are faster and easier to reach. The formula helps designer make evidence-based decisions about layout, such as how large to make buttons or how close together to place them. Interestingly, screen corners are the easiest to access because the cursor naturally pins against the screen edges. Though designers often overlook this, Fitts law has practical applications, especially for touch screens and mobile devices where every millimeter of space matters. For example, Nokia used it to optimize key sizes and placement on mobile keypads to balance speed, comfort, and accuracy. So, that's all for this module. I hope you had a great semester, and I hope to see you for your group project presentation. Um, Thank you all.